Hey guys, and welcome to Functional Print Friday, and welcome back to my shop. So this week I want to figure out how to get air into and out of my tiny little CNC milling machine. I think we have what we need in this box to get air into it, but getting air out of it, I think we're going to have to roll our own solution. Let's go take a look. We're around the back of my small little CNC milling machine here. This is the Makera Carvera Air. I showed you guys this on the channel before, but I've not actually used this machine since I showed it to you guys because I've wanted to get my shopvac connected to the vacuum port here and my shop air connected to the high pressure air inlet over here. So for the high pressure air in, we just need to figure out how to go from one of these 1/4 inch quick disconnect fittings into this fitting here, which I believe is an 8mm pneumatic fitting. And I think we have most of what we need over in that box on the workbench to get the high pressure air connected. We might need to figure out some sort of valve or, I don't know, maybe like a pressure regulator. We could figure that out as we get to it. But what I think is going to be the trickier part is figuring out how to get the vacuum connected to this small inlet over here. Grab my shop vac hose, I'll show you what I mean. So here's the hose from my shop vac, and you can see just how big of a difference there is there in size. And also, I don't think I want it coming like directly off the back like that. That's going to put a huge strain on this. The shop vac is going to be over in that direction. So I'd kind of like to have this connected either kind of coming down maybe. See, there's an air intake here though. Or maybe at an angle like that. Or actually, since gravity is going to be pulling down on this, probably like an angle like that would be ideal. So we need a way to securely mount something to the back of this. And we need a way to get from that diameter to this diameter. And I don't want to go into the inside of this. That would probably be the easiest way. Just design something that slips into this and then opens up to this diameter, but I don't see how it's going to stay in place if we don't have it attached to the back of this somehow. And I want to go into the outside of this. Even though this does neck down a little bit in there, I want to maximize the amount of air that we can get through this rather small tube in there. So I'd like to fit something that just kind of snags this on the outside. And I'm hoping that we can use these 4 screw holes to maybe attach something back here. So like what if we made like a plate that covered sort of this whole region, attaches with these 4 screws. I guess we really only need like an access hole to get to the pneumatic fitting. It would ideally tightly fit up against the OD of this. This actually, it's probably hard to see from the angle you guys are at, but this protrudes past the back housing here by a little bit, maybe 1.5 mm, 2 millimeters. So slipping over the outside of that with the plate straight against the back of this. And the whole thing would either come down like this or like this. So to get the measurements for this, I'm going to try and reduce this to the minimum number of things that we need to measure because we don't really need to model the exact location of all these things. I think we can get there with a couple simple measurements. It looks to me like these screws are in a rectangular pattern. So I think we only need the measurement of the center point of that screw and the center point of that screw, and then the center point of this screw to the center point of this screw. We could put a rectangle there and then locate each one of those screw holes on that rectangle. We'll need the diameter, the outer diameter of this. I guess we don't really need the exact diameter of this, but we'll probably get it and then just add a little bit to it so that there's clearance in there, because I'm going to want to be able to probably like reach in there with either my finger or a tool and push that to release it without taking our plate off. And we'll need the position of, let's see, vertically, it looks to me like both of these are centered between the 2 screws. But we will need the position of the center of each one of these holes away from, I guess, the screws on each side. So I'm going to get those measurements. I'm going to get started in CAD, and I'll bring you guys back. All right, and here is the initial design that I came up with for this. I'm going to try and walk you guys through at least the key steps that I took here in CAD. And thank you to everyone that left a comment in last week's video. Many of you pointed out that I should be using the variables. This is now only the second thing that I've designed here in Onshape. And this week, that's the very first thing I did. I took all the measurements of everything that I figured we'd need first, and I went and I typed them right into the variable table here. So the size of the screw holes, the intake from the CNC, that would be this diameter here. Outlet to vacuum, that is our diameter out here where the vacuum hose is going to plug into. Base thickness is the thickness of our plate here for our piece where it mounts up against the Makera CNC. Tube wall thickness is the thickness of the tube that comes out here. And air inlet is the diameter of this hole here. That one's not really a key measurement. That's really just clearance. But by typing all those in first, that part's done. I can just then reference them as I reach that part of the drawing. So let's open up the base sketch here. This is what I started with. And if you guys recall, I said when I looked at those screws that it looked like they were on the pattern of a rectangle. So the first thing I did is just draw a center point rectangle starting from the center point of the sketch outwards, and then put the screw holes in there. And I referenced, you can see as I roll over it there, you can see rather than typing in the size, I just typed in the variable name, and it auto completes for you. As soon as you start, you type the hash, you get a list of variables to select from, so you don't even need to remember the exact name. Like I have the variable table open now, but we could have this closed, and it's still going to do it. One thing that I've learned since sketching this, now only like one day ago, is I ran into a bit of an issue here. I wanted to keep the rectangle because if I didn't keep this rectangle, it's going to complain that the sketch is under constrained. And in later operations, I then had a challenge selecting just this bore. Like if you're selecting, like in the sketch here, if we roll over this, I can get that diameter. But when you're looking to select like the face to extrude it or for other operations, notice I don't get the whole thing. Where it intersects that rectangle, like I don't get part of it. So it's a whole bunch of clicks to get the right thing. I realized, and you guys tell me in the comments if I'm doing this wrong, but I realize now that you can actually select those items and then make them just construction lines. So if I click on construction, they'll turn into dashed lines. And now, if you'll notice, regardless of how I roll over this diameter over here, it doesn't try and grab like where it intersects that, because it knows that I just have that there as a constraint in the sketch rather than something that I'm actually going to want to use to extrude from later on down the line. So that is one thing that I would have done different and that I will be doing differently than the next sketch or the next thing I design here in Onshape. Next thing I did is an extrude. So if let's see, let's close our sketch. You can see I extruded the base and did that with a variable as well. It says depth 4 millimeters, but if we roll over that, you can see that's actually the variable. And then I extruded the screw holes through there, and that would have also been easier. Notice you can see the edges of that rectangle because I did not do that. I hadn't actually converted that to construction lines in the base sketch, so that's going to be like probably either 3 or 6 less clicks next time. Then I extruded the clearance for the high pressure hose to plug in on this side. I created an additional sketch, and this one was actually really tricky. This is going to be the path for the loft from the small diameter over here to the larger diameter over here. And what made this tricky is, if you notice, the plane of that sketch does not follow the plane of anything existing here in the design. And what I mean by that is, normally when you're going to do a new sketch, you'll click on an existing face. So like I would click on, say, this face here, right click and hit new sketch. And it's going to create a new sketch that is on the same plane as that face that I clicked. Well, since I wanted that path to be 45 degrees from any of the planes in the sketch, when I created it, let's see, where did that sketch go? That one is, nope, not that one. It is this one. What I did, first, you want to put your mate connector on the sketch. So if we do another sketch in here, sorry, let's get out of this one. Notice when we open up a new sketch, so we'll just click on a face, new sketch. That sketch has a mate connector that I think by default is just falling in the center point of the sketch, if I recall, which is fine if we're sketching on a face. But if we go back to that sketch, I wanted the mate connector, the center point of the sketch, to be exactly on the center point of that bore, because if we move that guy around, like let's say we move that around later on, then our path for the loft would not be in the right position anymore. So that was half the battle. The second part of it was, after you set your mate connector, you can actually click on this and set a rotation angle. I had to look that up. It took me a little while to figure out how to actually change the plane of the sketch. So it's at 45 degrees or minus 45. So like if I make this, say like negative 25 degrees, just so you can see what happens. That's going to change the plane of that sketch relative to where I originally defined the sketch from, which I think was this face over here. So we'll set this back to -45. Close all that out. And then once I had that sketch in place, I used the loft command to follow that path that we defined in the sketch. And you know, the loft command, it seems like it's a little overwhelming at first. You have to remember when you apply something like a loft or even a chamfer or any of these more advanced tools in here, you get a whole bunch of things that you essentially are used to drive where that loft is from. So profiles, face of sketch 3, face of sketch 2, I'm basically defining the endpoints. You can see it's highlighting them here in orange. That's where I want the loft to run from out here to over here. And that's what those additional 2 sketches are. There's a sketch on this plane over here that defines the endpoint that's attached to that path. And then same thing over here. And then you select path. So without that path, notice the loft just tries to kind of, you know, draw the simplest shape possible between the two. But since I'd already defined that path, I can click on path. And then you can see here, I've defined that path by this segment here and this segment over here. And that's it. Just selecting that path, it automatically creates all the geometry in between to get you that feature, which, you know, ends up looking like a rather advanced thing to draw, but in reality, it's basically doing it all for me. Let's see, sketch 4, I think this is, okay, yeah, so this is the sketch that I designed, because I'm at this point here and I'm thinking, okay, well that should work, but it's not gonna be very strong. We have, you know, not a whole lot of space between the edge of where this guy attaches and then all the way down into sort of this larger horn shape. I was a little worried that might break off. So by sketching that and then extruding it, back out of here, and we look at that extrude, that just extrudes up and fills in that region there to give that guy a bunch of extra strength. And then pretty much everything below that is just fillets and chamfers to kind of give everything a nice clean look. One thing, oh, I did do, yeah, so you see an extrude here, there's a small sketch there, and then an extrude here. What that's doing is giving us clearance for that screw. Without the extrude that cuts into the wall of that lofted section, I don't think we'd be able to get that screw in there. I didn't try, but I figured there's no way we're going to get that in there. Even if we did just like a small chamfer down here, we need to sort of cut up into that guy a little bit. And I think that's pretty much the whole thing. I'm amazed at how cleanly it creates the geometry in that loft. We can go in here into section view, click on a face, and you see as I cut through that, we can actually change the angle of this too. Like, look at how clean that is in there. And I also use this to see how much room I had for this section that I extruded up in here. I wanted to make sure I didn't cut too far into that wall. You can see it gets pretty thin there at that one point. Change the angle a little bit better. Now look at how clean that geometry is through there. I don't know how I would have drawn that by hand. I mean, you know, you'd have to be crazy to try and draw that by hand anyway. The point is to let the CAD software do it. But you can see how clean that path is through there, because, you know, this is really important. We have this large diameter here that we're trying to draw air into, and we have a much smaller diameter over here. So how clean this geometry is inside and how smooth it is really going to impact how much flow we actually get through this. If this was like just a rough boxy section with a right angle, even with the same diameter on one end to the other, we wouldn't be able to actually flow as much air through there. All right, so let me know down in the comments if that was useful seeing that. I might even consider, as I get a little bit more comfortable here in Onshape, actually just, you know, maybe doing like a live design from beginning to end. So let me know down in the comments if you'd be interested in seeing that. But let's get this guy exported, sliced up, and printed out. Okay, while that's printing, let's see if we can figure out the high pressure side of this. And I'll put a link to this kit down in the description of the video. I initially tried to just buy a length of the tubing and the exact fitting that I needed to go from this tubing to the quick connect fitting. And that ended up being more expensive than just buying this whole kit. I think we're gonna have a lot of pieces left over for future projects. Although that said, I guess we should probably start by making sure that this is actually the right size tubing. Let's check that. All right, let's just make sure that this does actually fit in here. Yeah, that's locked in. And if we push that in, a little tricky with the one hand, but got it out. All right, so we know this is the right size tube. All right, so let's dump this out and see what we got in here. Oh, it's probably for cutting the tubing. I didn't even realize it came with that. That's nice. PTFE tape. Okay, so I think we're gonna want probably one of these guys. That'll go from our tubing to one of the quick connect fittings that fits inside here. Let me go grab my air compressor stuff. In case you wondered what I meant by air compressor stuff, I meant air compressor stuff. So we want, I think, one of these. Yeah, that's gonna go in there. And that looks like that is gonna fit in there. So I think it would be as easy as that. Although, if we do that, so once I push this guy into here, we're just gonna have air coming out of there as fast as I have the regulator set on the air compressor, which is in the closet. So if we do that, there'll be no way to turn the air off or to control the pressure without going all the way over to the closet. All right, I've got this small regulator. I think this works. I'm not sure what I took this off of, but I probably wouldn't have kept it if it didn't work. Don't actually remember what this was last on or why it would have this weird fitting on it. But I think we could use this essentially as our valve and as a regulator. I mean, we wouldn't be able to keep a set pressure. We'd be setting the pressure each time. But if we put this in line between the two, we'll have to cap that off. Probably have something in here to cap that off. If not, just whip something up on the lathe. Actually, I guess it might be beneficial to have a pressure gauge there. This also probably still works. So we don't want this, we want probably this. That should thread into there, that would go into there. Pressure gauge at the top, and then this guy into here. I think that'll work. Let me get you guys moved over a little bit so you're not right in my way. Let's see if I can get this together. I'll give you guys a little word of advice. As much as I hate throwing stuff away, the PTFE tape that is included with stuff, just throw it away. It's not worth your time to try and use this. It's usually like the thinnest, junkiest PTFE tape. And don't buy cheap stuff either. I will put a link to this stuff down in the description of the video. This is Polytemp HD. This stuff is so much better. It is probably 2 to 3 times as thick as that, and I don't think I've ever put together a threaded fitting with this stuff and had to take it apart and do it over again. All right, that went together pretty easily. Hopefully we don't have any leaks. All right, so if we want to cut a piece of this off, we're going to have plenty left over. I don't really know how big of a lead piece we need here. Let's just start with like 2 feet. Oh, that actually works pretty well. All right, so this side's going into here. And then this side, let's see, are we all the way off? Is this a valve here? All right, I've been looking through the manual for this, and sure enough, this is an air adjustment valve. And at first I didn't understand how to turn it. It locks and unlocks. You push it in to lock it, you pull it out to unlock it. And with it turned all the way clockwise, the air does completely stop. There's no leaks, which is good. And if I turn it counterclockwise, I get airflow. So I could probably use the regulator that we have on the leader hose in the back to set what the maximum flow I would ever need is, and then just use this to adjust. All right, I cranked the regulator in the back up to 50 PSI, and that definitely seems like plenty. So I think we can call that done. All right, our V1 print is done. And all I did was pop it off the bed. I figured you guys would probably want to see me remove these supports because I printed this on the Bambu Lab H2D. And while that machine is pricey, I'll admit, being able to work with two different materials in the same print without worrying about flushing the nozzle is really nice because you can use a different material for the support interface. So you see the supports on this are the same as the model itself. They are PETG-HF. But the support interface, you notice, is white. That is just plain old PLA. So these should come off super easy. Let's see. Yeah, look at that. And look at how clean that surface is. Could we have done that with regular supports? Yeah, sure, but man, was that nice. Oh, look at that. There's literally no cleanup work to do. The part is done. Let's see if it fits. Oh, that fits. Yeah, the inside of that bore fits really nicely over that guy. There is just the tiniest bit of play in it, so we're good there. Could be the angle, but that doesn't look centered to me. I might have gotten that measurement off. I mean, it's just clearance. It doesn't really matter. We just need to be able to reach in there and push that to disconnect it, but I'll probably adjust that. I guess, well, we won't even get our screws in if I don't have this one in the right position, so let's see. And the screw holes aren't big enough. I did pop one of these screws out and measure it with the caliper, and I added 0.2 to it. I guess I should have added more because that is, I could probably force it in. The problem is if you do this, like this will thread into that hole, but then we're going to end up with a gap between the back of this plate and this surface because the threads are not going to line up on the inside of that bore and where the threads happen to be here. So I guess we could drill them out for our test piece here. Let's go do that. All right, so these are just under 3 millimeters. I think I made these holes, I want to say 3.2 millimeters in CAD, but they closed up a little bit while printing. See if we can get an actual measurement. Wow, they closed up a lot. Yeah, that's like 2.75 roughly, a little bit less. Let's drill them out to 3. 3. Yeah, that's perfect now. This little drill is really nice for this kind of stuff. This company wrote me a while back at this point and wanted to send this and their air blower for a review on the channel. And I said, yeah, I'm not going to review this on the channel, but if you send it and I actually like it, you'll probably see it on the channel. Sure enough, you're seeing it on the channel. This thing, what I really love about this is the distance from the center line of the bit to the side. Let me go grab even my small drill. I'll show you what I mean. So this is a very small hand drill. And if you look at the distance from where the bit would be in this to the side of the drill body, it's, I don't know, probably 30, maybe 30 millimeters. Yeah, maybe, no, it's probably right on, about 30 millimeters. This guy, because the whole thing is so slender, will let you get up a lot closer to stuff. Yeah, this is like less than half of that, maybe 12? Yeah, probably about 12. Now, you're limited on the bits that you can use, and the big thing that I don't like about this is, and I guess this comes along with it's a Pro and a Con. Because it's so compact, they wanted to, I think, keep the profile all the way around as small as possible. Well, it rolls. And you notice there's a broken bit in here. This is only the 3rd time I've used this, and I've already broken one of the bits because you guessed it, I set this down on the workbench and it rolled off and hit the floor. And I guess it's kind of good that this is probably the heavy end, probably just like a little motor in here and a gearbox. So it hit the floor like that, broke the bit off. Well, I can't find replacement bits for this. So I don't know what you're supposed to do when you break a bit. I did write them and say, hey, I love the thing, except for the fact that it rolled off my bench I think first time I used it. And they don't sell replacement bits. So Fantic, if you're listening, you got to sell replacement bits for this. It's a neat little tool. The back here is just like a lock and an unlock. It doesn't do anything when it is not in the unlock position, and when it's in the unlock position, you have forward and reverse. It's got a high and a low. I don't know what you'd ever use a low for. The smaller the bit, the faster you want to go. Like, that's way too slow. Like, you're always going to be in high. I don't know why they bothered having a high and a low. And even though this has a collet on it, it's really only designed for like the one size shank. All the bits in here have the same size shank on them. You know, these look like maybe PCB drills. I wonder if I could find a set of PCB drills that have the same size shank. Let me know. Let me know down in the comments if you know where to get drill bits like this. Are these PCB drills? Yeah, they're right on. Well, maybe 5/10 under. Looks like it's a 1/8 inch shank. Actually, we want to leave that one in there. That screw stays in place. It's catching a little bit, I think. No, actually, that's sitting up against there. I think we're in the right position on this side, which is the more important side to be dead on with. Got a little pocket there, gave us plenty of clearance to get that screw in. That's nice. Okay, all the screws line up. I don't know what I'm actually tightening on inside here. I don't know if there's inserts or if that's just going into plastic, so I'm not going to over tighten these. It actually feels nice and solid. Grab the vacuum hose. All right, I guess it was probably wishful thinking to think I was going to get that on the first try. Although it doesn't even seem close. I kind of figured it at least start in there. I wonder if maybe, you know, I took it for granted when I measured this that it was a perfect circle. The reality is this is probably ovaled a little bit. I probably measured it where it was a little narrower. I'm going to measure this again and we'll adjust that. I mean, the good news is, so far, let's see, we want to adjust the position of that. That was not a variable, but that should be easy to change. The screw holes, the size of where it mates against there, and the internal diameter of this are all variables. So we can update those all very easily. So let's do that. Print out a V2. All right, so here's the beauty of having everything in this variable table. So we want to change our screw hole. Let's go to 3.5. And actually, let me zoom in on this so you guys can see this updating live. So 3.5, okay, it changes the size of our screw holes. We're going to do a little bit more clearance here. It felt like maybe it was slightly misaligned to the screws. It did go in, but we're just going to add 0.5 millimeter. So we'll go 26 on that. You can actually see the size of that bore increase. Base thickness we'll leave alone. Tube wall thickness, I'm happy at 3. We do want to change the outlet to vacuum though. We're at 57.86. Let's go. That must have been exactly the measurement off the calipers. I should have added something to that. So let's go 58.75. All right, that opened up in the end. And that's it. We're done. Now all I have to do, I mean, we didn't do anything other than just edit things in the variable table here. So I'll go ahead and export this, slice it up, print it again. All right, our updated part is done printing, and this came out just as nice as the first one. But I guess there's no point even putting this on if the vacuum hose doesn't fit, so let's check that first. Oh wow, that's perfect. I'd love to say that was skill, but that's probably more luck than skill, but that goes in like, that goes in about 80% of the way, so that's dead on. Happy with that. See if the screws fit. All right, here's one of our screws. Yeah, that's right on. All right, let's try it. I also moved this hole over, I think this way, by about 1/2 millimeter. Let's see if that looks centered now. Yeah, it's probably a little hard for you guys to see at that camera angle, but that, to my eye, looks like it is now in the center of our clearance hole there. So that's good. All right, I can't fit my head back here, but I can fit you guys. Does that look centered to you? It looks centered to me here on the screen, so I think we got that. So for whatever reason, that side, the center of that hole was 12.5 millimeters away from the position of the screws instead of 12 millimeters like the position of this side. We got it. Oh yeah. Yeah, that's nice. Yes, it has a surprising amount of suction. I was worried that the large shop vac hose, reducing it all the way down to this side, that we weren't going to have that much negative pressure there, but that has a surprising amount of suction. I think that's going to work really well. Well guys, I am really happy with the end result that we have here. I don't think there's anything I would change at this point. Curious to hear what you guys think. Let me know down in the comments if there's anything you would have done differently or if there's any improvements that you can think of for this, but I'm pretty happy with that result. Guys, as always, thanks for taking the time to hang out in the shop with me here for this week's video. It's always really nice to have you guys along. And special thanks to the patrons that support this channel on Patreon and make this content possible. And if this is by chance your first time here on the channel, this is all we do. It's all functional printing and the design and engineering and tools and fun stuff that goes along with that. So if you like that sort of thing, check out some of the other videos on the channel. And if you like what you see, hit that subscribe button. And guys, if you do, I'll see you on the next one.